Here we're told that the voltage across an air-filled parallel plate capacitor is measured to be 85 volts. So I have that here, delta V C naught is 85. After we insert a dielectric that completely fills the space here, the voltage drops to 25 volts, so delta VC is 25. We want to figure out what is the dielectric constant of the material. Well, we know that the final capacitance is equal to K epsilon naught A divided by D. And we know that the initial capacitance is equal to epsilon naught A divided by D. So the only difference here is this has a K and this doesn't have a K, right? So then we can say that CF divided by CI is equal to, we just have K epsilon naught A divided by D divided by epsilon naught A divided by D. And we see that everything cancels out except for the K. So we know that if we figure out what this ratio is, we figure out what the dielectric constant K is. Now the good thing is we know that CF can also be written as K naught divided by delta V. And that's going to be delta V, the final one, right? So the final capacitance, so here, this is the final, and this is initial, is equal to Q naught divided by delta VF. Initial capacitance is equal to Q naught divided by delta V I. And the reason why Q naught doesn't change is because there's the same amount of charge both here and here. So there's the same amount of charge on this plate before and after we add the dielectric. Now we know what delta VF is, right? So this is after, it's 25, and initially it's 85. So this is equal to Q naught divided by, I should just say 85 volts. Sorry, afterwards we have 25 volts. And then initially we have 85 volts, right? Initial 85, final 25. So then we say, okay, well, what is CF divided by CI? Q naught divided by 25 volts, and then divided by, so 85 volts divided by Q naught, cancels, we get 85 divided by 25 is equal to 3.4. And that is our dielectric constant, K, right? So that is A. Now B says, can you identify the dielectric? So what is it? This, you're just going to have to Google, and you can figure out that it has a dielectric constant that's pretty close to nylon. C says, if the dielectric does not completely fill the space between the plates, what could you conclude about the voltage across the plates? So here originally, right, it went up all the way to the edges, and we're told to think about a situation where we have a parallel plate here, and then our capacitor that maybe it only fills up a little bit of that spot. Now we know that V drops as dielectric is inserted. The more dielectric that gets inserted, the more V drops. So we know that whenever we had the situation where the dielectric material covered the entire space, V was at its absolute lowest. So that means our new, and here I'll just write that as 25 volts. So we know 25 volts is the absolute lowest our potential difference can get, and that is when our dielectric constant fully fills it. Now the opposite scenario, right, is when we had literally no dielectric. So we know that that was 85. That means that if we insert a smaller dielectric, well, we can figure out what that is by like calculating it or measuring it or anything, but we know that it is going to be somewhere in between 25 volts and 85 volts. And that is all the question was asking us to do.